In problem 18 in chapter 18, Bhattacharya and his co-authors are trying to illustrate the point about firm-specific human capital motivating employees to accept the fact that they're being pooled with more sickly employees, and thus they're getting paid less because, at least to some degree, the level of sickliness is unobservable. All right, let's explore this problem a little bit. I've imported the text of this problem. There's a lot of words to it, and basically they're just giving you some stylized facts and then walking you through some economic logic that you probably haven't seen before, but that's why I'm here to explain it. The key points that come out of the setup are that there's sickly workers that get sick with a probability of P sub S, and that remember, that's the probability that a sickly worker will get sick. There's, on the other hand, robust workers, and these are the ones that we wonder, why don't they jump ship and be with only robust workers, or at least go to an employer that doesn't provide health insurance, and then they can get the full value of their contribution to the firm in wages and buy their own. All right, and we know that the probability of being sick for a sickly person is greater than the probability of being sick for a robust person. So, and then these are unobservable. P is unobservable. At least to the employer thinking about whether to hire one person or another. Moreover, the company can't offer insurance to some and not to others. It either has to offer insurance to everybody or to nobody, and that's per U.S. law. That's sort of a stylized fact coming out of the reality of U.S. law. And then further, and this is going to be important as we think about what wages would be and what firm-specific human capital would do, the contribution of a new worker to a firm is the marginal product of that new worker. And it's we're going to say that's the marginal product times the price of the product. That's the value marginal product. So the new worker brings in, they contribute something to output, and we're going to call that marginal product, the value marginal product of the new worker, MP sub n. And what's more, the experienced worker also contributes something to the firm's output, and that's because of this human capital. Experienced workers that have been at the firm longer, just contribute more to output. So this is the firm-specific human capital right here. And this is a very sort of simplified model, but it brings home the point that will lead to part E, where Bhattacharya drives home the point he's going after with this problem. All right, so part A asks us if an employer is deciding whether to hire a new employee who will produce a marginal value product of MP sub n, right? The problem doesn't say sub n, but it's a new employee, so it would be MP sub n. If the employer offers income and no health insurance, at what wage will the employer have to pay in a competitive labor market? And in economic analysis, it's a very common outcome that firms are going to have to pay a wage just equal to value marginal product. And since this is a new employee, just equal to the value marginal product of a new employee. And if the firm offered less than that amount, there'd be another firm saying, "Oh, I could hire that employee at a little bit higher price than what the wage that one firm is paying, and I'll be able to make a profit because the value marginal product is above the wage that I'm having to pay that worker. So there would be a bidding process where other firms would say, hey, I'll pay you a little bit more if ever the wage is below the value of the marginal product. On the other hand, if an employer paid more than the value marginal product, well, then the employer is paying out in money more than what the value of the employee is to the worker and is to the firm, and the firm would be losing money. So this is the logic of the way in a competitive labor market. And that competition is a key assumption here. Workers are paid their value marginal product. All right, so now let's think about this fact of health insurance, and we're going to just think through the case where there are different premiums for sickly people, and that would be, the premium is V sub S, the premium you have to pay for health insurance for a sickly person, for a robust person, V sub R, and of course the premium for a sickly person is higher. So the question asks, what wage would an employer pay a robust worker in a competitive labor market if the employer could observe the worker's health state? Well, here the take-home pay, we'll call it RW sub R, the wage of the new robust worker would equal that marginal value product of that new worker minus the level of health insurance, minus the health insurance premium that the employer would have to pay on behalf of that robust worker. And then a sickly worker, if these conditions were observable, would be MP sub N minus V sub S. So this is all by way of setup, but it stems directly, this wage pass-through stems directly from the logic that workers are paid according to the value of their marginal product. All right, now we're moving a little bit further on, and if the employer cannot tell the difference between a robust and sickly worker, and they offer health insurance, all workers are going to get the same wage, and that's going to be equal to the marginal product. If let's just think about the wage of a new worker, obviously the wage of an experienced worker we can think of as well. The wage of a new worker is going to be that value marginal product minus now. Well, the workers are going to make, the new workers are going to make their value marginal product less the health insurance premium, and I'm just going to put a parenthesis around it. The health insurance premium is going to be a weighted average of the portion of workers that are sickly times the sickly worker premium, and then it's going to be the portion of workers that aren't sickly. If there's theta that are sickly, it's 1 minus theta that aren't, times VR. That's what it's going to be. And that is the same as saying, by the way, MPN minus theta VS minus the quantity 1 minus theta VR. I'm just multiplying through by that negative sign so I can remove at least one set of parentheses. And then, of course, the experienced workers, we assume that the health insurance premiums don't differ. The value marginal product of an experienced worker minus theta V sub S minus 1 minus theta, the quantity times V sub R. So now we move on, and this is sort of this cumbersome problem. We have more information, and here we're going to introduce this shorthand. D is going to be the difference. That's going to be the wage premium for experienced workers. It's the difference between the earnings of experienced workers minus the earnings of the new workers. And then So the question is, what will be the wage of the robust worker at the new job the first year there? So W, that first year, is going to be just the value marginal product of the new worker. And we're going to simplify. We're going to ignore the multi-period analysis you'd need to do this properly, and we'll just look at that first year's salary. So under what conditions will it make financial sense for a robust worker to change jobs? And I'm going to do that just logically, and then put it into terms of D, theta, V sub R, and R. So let me just start over here. So jump to the new company if the wage is at the old place. That's the value marginal product of the experienced worker minus the health insurance premium. Oh, and this worker has insurance at this old job, so we're going to have to, that insurance has a value, V sub R. And then, so this is what the person's giving up. And you would jump if that amount is less than the new worker wage without any health insurance premium taken out. And so that makes some sense. We can simplify this by noticing we have 1 times V sub R, and we have negative 1 times V sub R. So that's going to work out to be, let's go ahead and work that out. Jump if, so this is going to be, jump if MP sub E minus theta Vs, and now I'm going to, I've got a negative times a negative of theta Vr. If all of that is less than MP sub n, then jump ship. But notice we want to put things in terms of D and theta. So I can do some rearranging here. Notice that D is defined as MP sub E minus MP sub n, and then I'm just moving this term here. Let me get a pointer. Moving this term over to this side by subtracting MP sub n from both sides, and I'm just going to move. I'm going to add theta Vs minus theta Vr. I'm going to add that to both sides, and I'm going to get jump if the wage differential is less than the following: theta Vs minus theta V sub R, and that's if D is less than theta. Actually, I'll just call it theta times the quantity Vs minus Vr. So jump if that wage premium is smaller than the extra money in health insurance that robust worker that is finding pulled from his paycheck. And then once we get it into that expression, jump if D is less than theta times Vs minus Vr. Well, if theta is small, you're going to jump. If D is small, then jump. Otherwise, stay. And so the higher the D, the larger the fraction of employers would be offering pooled insurance.